Dear students, hello and welcome to our virtual chemistry class. This is Mohammad Asif Iqbal, Senior Teacher, Department of Chemistry, Milestone College. In this class, I am going to discuss with you two of the creative questions taken from chapter 9, which is acid-base balance. Before go through the lecture, I would like to give you some suggestion, and that is you must watch the class with utmost sincerity and write down the question in your own copy. Dear students, now come to the first creative question. You can see there is a reaction provided in the stem, which is hydrochloric acid react with magnesium hydroxide and produce magnesium chloride and water molecule, and the two compound is notified by A and B. Now first question, what is pH? What is pH? Number B, question B, pure acid does not conduct electricity. Explain. Pure acid does not conduct electricity. Explain. C, question C, what type of reaction is there in the stem? Explain. So you can see the reaction and you need to explain what types of reaction it is and its significance. And the last one is write down the difference between the compound A and B mentioned in the stem. I repeat once again, write down the difference between the compound A and B mentioned in the stem. Now come to the question A. What is pH? Now you can see the pH of a solution is the negative logarithm of concentration of hydrogen ion present in the solution. You can see the pH of a solution is the negative logarithm of concentration of hydrogen ion present in the solution. Now I'm going to write down pH is minus logarithm of the concentration of proton ion present in the solution. Now what actually pH indicate? pH indicate the nature of the solution, whether the solution is acidic or basic or neutral in nature. If it is acidic, how much intensity of that solution is, or how intensely acidic this solution is, we can easily find out by observing the value of pH. Similarly, if a solution is basic, how much intensely basic solution it is, we can easily find out by observing the value of pH. We know the pH value of neutral solution is 7, and when the pH value is less than 7, the solution is acidic. When the pH value is more than 7, the solution is basic. Now I'm going to show you some very important thing you must remember in mind how you actually write down the pH. You must write P in small letter and H in capital letter. So that is all about the pH of the solution. Dear students, come to the question B. Pure acid does not conduct electricity. Explain. When we discuss about the acid solution, we classified acid solution in two different groups: dilute acid solution, concentrate acid solution. In dilute acid solution, the amount of acid or the concentration of acid is much less than the amount of water. But in concentrate acid solution, the amount of acid is higher than that of the water. So if we take any acid solution where water molecule is absent, what types of properties it show? For example, if I take dehydrated oxalic acid powder and we insert a blue litmus paper on dehydrated litmus paper, we can see that the color of the litmus paper remain unchanged. So acid can only show its property when it added with water. Without water, acid cannot decompose and cannot produce proton ion, and without the presence of proton ion, acid cannot show its properties. You can see, I'm going to write down some of the things For example, this is hydrochloric acid. When I add water, it produces hydrochloric acid aqueous solution, and in this aqueous solution hydrochloric acid dissociated and produce hydrogen ion and chlorine ion. Similarly, for the sulfuric acid, when we add water, that produce aqueous sulfuric acid and instantly it will dissociate or decompose and produce proton ion and sulfate ion, and the presence of the proton ion show the acidic properties. So when we take pure acid, the acid molecule remain intact, and that's why there is no free ion present in acid solution. But when we add water in acid and produce aqueous acid solution, in that time acid release hydrogen ion, and due to the presence of free ion, acid solution can conduct electricity. So we can say when acid is in pure form, its molecule remain intact. Therefore, due to the absence of ion, acid cannot conduct electricity. However, when we add water in acid, or when we add acid in water, the solution which is prepared has free ion, and due to the presence of free ion, acid can conduct electricity. So that's the reason behind the pure acid not to conduct electricity. Now students, question C. What type of reaction is there in the stem? Explain. So we can see the reaction in the stem provided is hydrochloric acid, magnesium hydroxide, and produce magnesium chloride and water molecule. So this is a neutralization reaction. Now, what actually neutralization reaction? The reaction in which acid and base react with each other and produce salt and water are known as neutralization reaction. I repeat once again. The reaction in which acid and base react with each other and produce salt and water, that reaction is known as neutralization reaction. So this is a neutralization reaction. I'm going to write down some example of neutralization reaction. You can see hydrochloric acid react with sodium hydroxide and produce sodium chloride and water. You can see hydrochloric acid react with sodium hydroxide and produce sodium chloride and water. Similarly, sulfuric acid react with sodium hydroxide, and in the same way it will produce sodium sulfate plus water. In these two cases, there is something very common. You can see hydrochloric acid, which provide hydrogen ion, and sodium hydroxide, which provide hydroxyl ion, produce water molecule, and sodium, which come from sodium hydroxide, and chloride come from hydrochloric acid, produce salt. Sodium chloride, salt and water are neutral in nature. Similar way, in sulfuric acid, hydrogen from sulfuric acid, hydrogen ion from sulfuric acid, and hydroxyl ion from sodium hydroxide produce water molecule, and sodium from sodium hydroxide and sulfate from sulfuric acid produce sodium sulfate. In this case, both of these compound is neutral in nature. So what actually happening in neutralization reaction? In neutralization reaction, acid lose its respective acidity. Similarly, base lose its basicity. So the compound which form after the reaction is neutral in nature. So this is a neutralization reaction. Now, what is the significance of neutralization reaction? Neutralization reaction is very important in our everyday life, in our agriculture, in dental care, and also in different types of biochemical reaction in human body. In digestion, when excess amount of hydrochloric acid is produced in our stomach, that cause different types of stomach pain and gastric. In this case, we actually take antacid, and this antacid is the mixture of aluminum hydroxide and magnesium hydroxide. These aluminum hydroxide and magnesium hydroxide react with excess amount of hydrochloric acid and produce magnesium chloride, aluminum chloride, and water molecule, which is neutral in nature. So this is an example of neutralization reaction. In agriculture, when plant take calcium, magnesium, potassium salt from the soil become acidic and loses its fertility. In this case, we add lime or calcium oxide, which increase the basicity of the soil and soil become fertile. Similar way, when we take different types of sweets, when we eat different types of sweets, it cause different types of problem in our mouth. There are millions of bacteria which react with these sweets and produce different types of organic acid. This organic acid started to erode the enamel, which is the outer layer of our tooth, and which cause the erosion of the tooth. To remove this problem, we take toothpaste which is alkaline in nature. Now, question D. Write down the difference between the compound A and B mentioned in the stem. I repeat once again. Write down the difference between the compound A and B mentioned in the stem. So you can see the compound A is hydrochloric acid and compound B is magnesium hydroxide. Actually, hydrochloric acid represent the acids and magnesium hydroxide represent the bases. So the meaning of the question is write down the difference between acid and base. Now, students, you can see that acid donate hydrogen ion in aqueous solution. Acid donate hydrogen ion in aqueous solution, whereas base donate hydroxyl ion in aqueous solution. So acid donate hydrogen ion and base receive hydrogen ion. Number 2. Number 3, the when acid react with base, it produce salt and water. Similarly, when base react with acid, it produce salt and water. Now, the taste of the acid is sour. On the other hand, actually don't take the taste of the base. When we take the base, we can find that base is slippery in nature. And the next one is the pH value. The pH value of acid is less than 7. The pH value of acid is less than 7, whereas the pH value of base is more than 7. The pH value of base is more than 7. Acid turn blue litmus into red color and base turn red litmus into blue color. I repeat once again. Acid turn blue litmus into red color and base turn red litmus into blue color. These are some differences between acid and bases. Now, student, come to the question 2. Creative question 2. You can see some reaction are provided. The first reaction, calcium oxide react with water and produce A, which is not mentioned what actually A. In the second case, ferrous chloride react with water molecule and produce B and hydrochloric acid. And third one, aluminum chloride react with water and produce aluminum hydroxide and hydrochloric acid. Now, the first question A, what is acid? Question B, why is nitric acid kept in brown color bottle? Why is nitric acid kept in brown color bottle? Although the compound A, we can see A is alkali, but the compound B is not. Explain. And the last one, question D, what types of change are observed when caustic soda is added with reactant salt given in the given in the reaction 2, 3, analyze. That means when we add caustic soda with ferrous chloride and aluminum chloride, what types of change will be observed? Question A, what is acid? What is acid? The answer will be an acid is a molecule or ion capable of donating a proton ion, which is an hydrogen ion, or alternatively capable of forming a covalent bond with an electron pair. I repeat once again. An acid is a molecule or ion capable of donating a proton ion, which is a hydrogen ion, or alternatively capable of forming a covalent bond with an electron pair, that is known as acid. Now I am going to give you some example of acids. You can see hydrochloric acid, sulfuric acid, in some extent ferrous ion, ferric ion, and also aluminum chloride also act like an acid. So which compounds are actually acid? Acid is a compound or ion which can donate hydrogen ion or can create a covalent bond by using electron pair. Now there are some other properties that acid have. For example, acid can change the color of blue litmus into red color, and acid can react with base to produce salt and water. Question B, why is nitric acid kept in brown color bottle? I repeat once again, why is nitric acid kept in brown color bottle? So what is the rule of brown color bottle? Brown color bottle prevent the light to enter inside the bottle, and the nitric acid cannot expose in light. If nitric acid expose in light, it instantly decompose and produce water, nitrous oxide and oxygen. I'm going to write down the reaction on the board. You can see when nitric acid is exposed in air, it will produce nitrous oxide, water and oxygen. So to prevent the decomposition of nitrogen gas, we need to keep nitrogen gas away from the light. That's why nitrogen acid is always kept in brown color bottle. Now student, come to the question C. Although the compound A is alkali, but the compound B is not alkali. Repeat once again. Although the compound A is alkali, but B is not alkali. Explain. Before explaining this question, we must know that what are the alkalis. So you can see the definition: hydroxide compounds of metals or metal-like reactive radicals that are soluble in water are called alkali. You can see hydroxide compounds of metals or metal-like reactive radicals that are soluble in water are called alkali. Now I am going to show you what types of change take place in the reaction 1 and 2. You can see when calcium oxide react with water molecule, it will produce calcium hydroxide. And in the second case, when ferrous chloride react with water molecule, it will produce ferrous hydroxide plus hydrochloric acid. So we can see the two compounds which is formed in the reaction 1 and 2. In the first case we can see calcium hydroxide, and in the second case we can see ferrous hydroxide. Now come back to the definition of alkali. Alkalis are metals or metal-like reactive radicals hydroxide. So you can see this is calcium hydroxide, which qualify the alkaline properties. Similarly, ferrous hydroxide, here we can also see the metal and hydroxide ion. But the basic difference between calcium hydroxide and ferrous hydroxide is calcium hydroxide is soluble in water, but ferrous hydroxide is not soluble in water. And this ferrous hydroxide create a greenish precipitation. This ferrous hydroxide produce a greenish precipitation in the solution. That's why we cannot accommodate ferrous hydroxide in alkali family. I repeat once again, between calcium hydroxide and ferrous hydroxide everything is similar, but ferrous hydroxide does not dissolve in water. Due to not dissolve in water, we cannot accommodate ferrous hydroxide in alkali family. Question D. What types of changes are observed when caustic soda is added with reactant salt given in the stem 2 and 3? Analyze. I repeat it once again. What types of changes are observed when caustic soda is added with the reactant salt? What are the reactant salt? Ferrous chloride and aluminum chloride. In the reaction 2 and 3, analyze it. Now we know what actually caustic soda is. Caustic soda is sodium hydroxide. So when we add caustic soda with ferrous chloride, what will happen? We can see ferrous chloride, and we are going to add caustic soda. It will produce ferrous hydroxide and sodium chloride salt. This ferrous hydroxide cannot dissolve in water. Consequently, it creates a precipitation, and the color of that precipitation is green. So it creates green precipitation. It creates green precipitation when we add sodium hydroxide in ferrous chloride solution. Now, what will happen when we add sodium hydroxide in aluminum chloride solution? We can see what aluminum chloride, when we add sodium hydroxide in aluminum chloride, it will produce aluminum hydroxide and sodium chloride. This aluminum hydroxide cannot dissolve in water. Consequently, it forms a white precipitation. White precipitation. So what actually happened, I discussed by showing the reaction. I repeat once again. When sodium hydroxide is added with ferrous chloride, it will produce ferrous hydroxide and sodium chloride salt. This ferrous hydroxide does not dissolve in water. Consequently, we'll observe a green precipitation in the solution. On the other hand, when sodium hydroxide is added with aluminum chloride, it will produce aluminum hydroxide and sodium chloride. Between these two molecules, sodium chloride easily dissolve in water, but aluminum chloride cannot dissolve in water, and it will form a white precipitation. So observing the color of the precipitation, we can readily identify that first one is ferrous ion and the second one is aluminum ion. Dear students, hope that you have understood what is discussed in this class. If you have any query, if you have any problem, you can ask question to your respective teacher in your Zoom live class. Thank you for being present and hope